Hello, hi guys. Am I audible? Hello, am I audible to everyone?
Yeah, you're audible, but voice is little low. Yes.
Just a minute. Yes, I'm connecting my headphones. Oh, then I'll share. Okay, I hope now it's audible properly.
Yeah, you're here.
So we are starting with Panda's session today. I hope there's no questions as such in NumPy. And anyways, we'll be practicing more hands-on sessions, so it will be more clear in future sessions as well. So as we are first of all moving towards the Panda, so first we'll understand few concepts of Panda, and then we will see the hands-on of all the functions that are available. So similarly, like if you relate to any Excel or a CSV data. So Pandas is something like that, which lets you work with your CSVs or the data, which is in a format which looks alike like a Excel or a CSV, so that you can do all sort of transformation, data analysis, column renaming, or addition of the data, or if you want to add any new column, or if you want to filter any kind of a data from your whole data set. So for that matter, we'll be using the pandas library. In pandas, there are two things basically. If we like make a difference between the what actually pandas is, so it is a combination of a labeled data and which is also called as a data frame. So 1D labeled data will be a series data set. 2D tabular data will be a data frame. So the moment 2D data comes into the picture, that means it is a tabular data, which includes rows and columns. So as we have also seen in dictionaries and in lists, and mostly in the dictionaries, also in the NumPy, that if we have rows and columns, so it's better for us to fetch the data in by using those indexes, by the position numbers. When I say the position numbers, how will you actually define those positions when you are actually talking about Excel data or a CSV data? So those positions are usually defined in terms of rows and column, that which what is the number of row and what is the number of column that you're talking about, so that you can fetch that actual cell value. Mostly we'll be working with data frames, but we'll see example of series as well, but series are not used in Panda, talking in context of GIS datasets. So all the GIS datasets that we'll be catering will be in the data frame format, which will look like a 2D tabular data. So index labels rows. When I say index labels rows means when you look in any of the CSV data or any of the GIS format data, I have already mentioned that all the feature will be represented by a rows that you have in your table data. So that is why it is mentioned that index will label your rows, that what position or what number of feature you are talking about. Then if we are referring to the columns, so column will always be your fields, or it will always be like a column name, like if you relate it to the dictionary, so it will always be like a key that is representing your values in a dictionary. So column will be the keys, or you can say it will be the label, because keys are also the label that will define the whole values. Every single dictionary is like a feature. So if you look at in terms of a CSV or a tabular data, so every single row here will be representing an index or a that which feature you're talking about, zero feature, first feature, second feature, or what kind of feature you're talking about. Then when we are combining the whole data frame, so as we have seen that I have said multiple times that a single dictionary like holds multiple feature, and every single key can have a single data type value. And in NumPy also, I have mentioned a lot of time that NumPy can contain a single data type of arrays when you're creating a individual array. Unique array will have a unique data type. When we come to the pandas, so every single column will have a unique data type. So each column has a data type, and you have to define what data type you want to give to that particular column. Let's suppose we'll take an example. So we'll take a normal example of our data set where you are representing cities or a district, where each city and district also contain attribute information about the population. So population column can be in a integer value, because population cannot be in a string. Similarly, a column which is showing you a city name or a district name can only be in a string. It cannot be an integer, or it cannot be a float. So those are the reasons how we actually, before when you're creating your data or when you're creating your schemas for that matter, at that moment the first thing you have to define is what is the data type of your column. So that is the reason when we are understanding about the basics of Python, we have understood about variables, and then we have understood about the data types, that we have to really define the data types of every single column, and that should be exactly matching or should be compatible to what kind of a data you're trying to hold in that particular column. So same thing, Pandas is kind of a Python library which helps you with data manipulation, which helps you with data cleaning, which helps you with data analysis, and it always works with structured tabular data. Dictionary was also a form of a structured data. So we'll see how dictionaries are related to this. So pandas specifically, but are used to help you with work with only tabular data, means it is not mandatory to have a geometrical aspect. When I say geometrical aspect, means it is not mandatory that you should always contain any kind of a geospatial or any kind of a latitude or a locational aspect to your data set. Then only you can treat or analyze or manipulate that data frame using the pandas library. Like in a dictionary, when I said dictionary in general, it can contain without geometry information. But when it comes to the GeoJSON, when it comes to the geospatial dictionaries are mandatory that they should have a geometrical aspect to it. Then only that data set will be called as a GeoJSON data. So 1D is called as a 1D here means one dimensional, 2D here means two dimensional. 1D is like a series of a data, means you only have a labeled array. Last time I mentioned that Panda library is built on top of NumPy library. So here also, ultimately, it is an array, but you have structured it properly with the labels. When I say labels, means every single array that you are trying to create or every single column that you are trying to create is represented by some kind of a label, that this is the key that it belongs to. Here, we call it as a labeled array. For example, a population of cities. So how do we create a normal pandas data frame or a series? So first we'll see the series. So we have to import pandas as PD. You created a basic variable, anything. Here we have created S. PD we have used because we have imported the pandas as a PD alias. Dot series will help you make a series here. brackets, you have passed on your values, and then indexes, as I mentioned, that indexes will define your rows. So indexes here are label. So A index, and in the same order it will take. So if I take this and if I create this particular series, in the A label, it will be 100, in B label, it will be 200, in C label, it is a 300. And the data type is defined by the what kind of a value are you storing in those labels. Data type will not be defined by the labels, it will be defined by the values that you're trying to store on those. Series is not a representation of a table. Data frames are the representation of a table. This is just for the information purpose that there is something called pd.series as well, which you can create. But in GIS or in our use case, we will never be using the series coming forward in the sessions. We'll be always converting our data sets into a data frame because we will always be dealing with some kind of a tabular data, either geospatial or non-geospatial. In both contexts, we'll be only dealing with data frames. So
One
hence,
minute, sorry.
yes.
So here the column 2 is it's integer, but column A is string, correct?
Column, no, this is not a column right now. This is just a series that you have made, a
Oh,
single thing. There is no aspect of column rows right now. This is,
okay.
it looks like a table, but this is not a table right now. It's like,
Okay.
looks like just you have labeled the values with some kind of indexes like A index, B index, and C index. That's it. A series. There
Okay.
is no concept of rows and column. It's not like A is belonging to 1, 1 means first row, first column. No, not like that.
Mm-hmm.
100 value, 200 value, and 300 value. This is a single array or a single list that you had, and you just labeled that list with A, B, and C index. That's it.
Okay. So whenever we are going to give a single data type, like this is the format PD is different, but series and index should be the same command, correct? Whenever we are going to align like a single data type.
No, no, not this. Do not get confused whenever you are just series. Yes, you are right in this that series can only hold a single data type value. Means it's not
Okay.
preferable that you mix and match that instead of 200, I keep on writing A, B here.
Okay.
This is not
Okay.
not recommended and not preferred. Never you are allowed to do that. But series is just like thinking that in a single list, I put two or three things together in that one stock or in that one block of thing. You just named it, but inside that series as well, you just you wanted to have give a label because as I mentioned, pandas are a labeled array. Means you have to label all those array together.
Mm.
How do we used to create the array? In array as well, we can write multiple values like this. Okay, so it is an array, but right now there is no label to A, no label to
Okay.
B. So that was just an array. But the moment you included this index, the moment you included a label to those arrays that you have, it is now converted into a series. Why it is not a data frame? Because in order to have a data frame, you need to have a header. Header means name of the columns. You need to have those column values and all those things. There we don't define indexes like this. There indexes are like 0, 1, 2, just like every single row. For example, we'll open a normal CSV. Let's suppose this is a CSV. Here, is there any label to third row? Is there any label to fourth row? No, there is no label as such, but still, if I want to fetch this particular whole row, I can fetch it using the index, like the fourth index, fifth index, seven, but the labels are
Okay.
column names here. When we're
Mhm.
talking about this is a representation of a data frame. Labels are defined by a name of the columns or the headers for that matter. Whereas series is just like randomly you define set of values and still you are trying to define you are trying to give the name or the label to A, B, and B like that. Here.
Okay.
And there is no use case of series in terms of GIS data context. But in pandas, there are two things, that is 1D and 2D. 1D is the series and 2D is the data frame. So we will be going to use data frames for our use cases, which is a representation of a table. It's not a table, but it looks like a table. It's easier for people to understand that data frame looks like a table where you can, the moment rows and columns comes into the picture, we anyways get an idea that I can filter, select the values on the basis of the positions of the rows or the number of the column number and the row number. As I mentioned, every single column will have a data type. So if you have to define a data frame, so df, let's suppose I am creating a data frame. Df is equals to pd pandas dot data frame is the key which we'll be using for creating a data frame. Brackets, and then if you see now, this is a dictionary. So this is a single feature that you have defined a dictionary. Inside that, we have first column city, we have second column population. Then in that city column, I have three values A, B, and C. Like this, in the serial number column, I have these value. And then in track 4 column, I have these value. So similarly, in city column A, B, C, and in the same order, it will create a table like that. So if I just represent this whole data frame as a table, so this simply looks like that I have a city and then I have a population. So in the same order, it will just write everything. So A, B, and C, and then maybe 10, 20, and 30. So this is how we can convert a tabular data into a data frame, or you can create your own data frame. So simply, this is how you create a data frame. So I'll run this so you can see that it has created a data frame. In Python, indexes starts from 0. So 0, 1, 2. So this is the 0th index, this is the first index, and this is the second index, like that. NumPy, if I just relate it a little bit to the NumPy, so NumPy was like a raw material, means you have individual array value, and Pandas is like a organized Excel sheet or a CSV sheet. If you look at difference between the two, NumPy, well, there it was mandatory, it was homogeneous, that we need to have a single data type in a NumPy array. Whereas in Pandas is built upon the NumPy arrays only. The concept is same, but it is heterogeneous. It provides you a flexibility to have multi-data types together, but with the limitation that every single column needs to be in a same data type. Column can be called also as if you relate it with dictionaries, it is a key representation. NumPy, n-dimensional arrays. In Pandas, it is not an n-dimensional array. It is either in series or it is in data frame. We will be mostly using data frames. In NumPy, there were no labels as such to define every single array value that we had in that. But in Pandas, we have indexes and we have column names as a label to fetch those values, to select those values. And that is why it is indexes and columns label was important. And that is why they made the Panda library for use, because the moment data analysis comes into the picture, I need some kind of a functionalities so that I can get the data, I can filter the data, I can fetch the data, I can modify the data. So how will you actually get those values? Either with the help of index or with the help of labels. This indexing concept we have seen in everything, in list as well. I have told you about the slicing and the indexing. In dictionaries as well, we have seen about the indexing and the slicing. In arrays as well, we have seen about the Boolean mask and the indexing and how we can slice the values, how we can filter the values, those concepts. Same, the concepts are same, just the syntax and few things will keep on changing, how you actually use it. Okay, NumPy pure use case was mathematics, matrices, machine learning model training, all those things. Pandas is specifically modified to use it for data analysis and cleaning purposes. In NumPy, I haven't really talked about handling the missing data and how do we actually treat those things if, let's suppose, there is some in between array values missing. But in Pandas, there is a specific things like NaN and fill NA. These functionalities we'll talk about to handle null values or the missing values from your whole data set. And this handling NaN and missing values are the most important concept in whole data analysis, be it the GIS or any kind of, for that matter. Why? Because let's suppose you have a data. We'll take this population data for the whole country, and for some reason, for some city, it is NA. So do not get confused with 0 and NA. So 0 and NA are two different things. NA is like, or the missing value. 0 is like that you're giving that, okay, the population is 0. NA and missing value means that there is nothing present in that particular cell. So why we have to treat those NA value and missing value before doing any kind of a pandas operation? Because in case you haven't treated or you haven't really done anything about these values or these cells, so what will happen if you, let's suppose you are doing, you are running some operation of sum, that I want the sum of all the city, or you're trying to calculate the minima value, or you're trying to calculate a maxima value. So it can throw the error because pandas or Python don't really understand what to do when I have this NA value or I have missing value, because it can't take that value as a 0 also, because 0, for it to be, for Python to read any cell value as a 0, it needs to be 0 only. Sometimes NA value can also look like this, minus 9999. So, and when you load any data, this doesn't really means, even if you filter like this, that okay, fine, filter minus 49 value, maybe you don't get that value. So these are missing records, or you can say that the invalid values that your GIS dataset can hold, your raster dataset can hold. So we'll only also look into handling all these values before actually performing any kind of analysis and moving forward with your dataset. So in pandas, there are function called NaN and fill NA, which will automatically detect those kinds of cells or those kinds of pixels in sense, in terms of the raster data, to get those value, detect that value, and then we can replace those values with whatever values we really want to put in those cases. So we'll see the handling of the NaN values as well. Okay. One more thing, can we convert arrays into a data frame? So yes, we can convert the same arrays into a data frame. The only thing that is on top of the normal arrays is that you need to give the label to those arrays. So pandas we have already imported, but NumPy we haven't imported. So I will import a NumPy. I am creating a basic NumPy array here in the array variable, and then I'm trying to convert that array into a data frame. But in this array, there are only values. I need to define the column. So since I have two values here, so I will give two columns here, two rows. So like this, it has defined. So 0th index, first index, A and B. So in A, it was this 1, and then 3, and then in B, it is 2 and 4, like this. So we can also convert normal arrays into a data frame as well. If we look into the difference, what is the role in terms of the role? Math operation, normal distance calculation, or any kind of a vectorized computation we have to do, we will use only the NumPy library. The moment tabular data comes into the picture, filtering location or group by the region, those kind of use cases will come into the picture. We'll be using the pandas library. Then index will give you row labels, columns will give you features or what is the field name or any kind of such matter in the pandas. In the pandas data frame, what are the functions that are available to get you those row labels or the column names or the data types? So imagine DF is a data frame that we have created here, the same data frame. And then if you want to know that what is the DF index, what is the DF columns, what is the DF dot data types, means data types, you will have to use the same variable name, dot index, dot columns, and then dot data types, dot D types. If I run this part, so df.index gave me this because, and then df.columns gave me the name of the columns and data. If let me do this individually. Because there was no as such row labels in this, that's why we haven't got any row labels in this. It is just starting with 0 and stop at 2 and step by 1. So it is just showing you that how many indexes are there. That's it. At step 1, that there are only these, not this. That there are starting from 0 and then it is just till 2. It is showing us that index values here. If I show you the name of the columns, so it will show you the name of the columns here. Then if we look at the df.data types. So now it is giving me data type individually for both the columns. That A column is integer 64 and B column is integer 64 here. Okay. Then in order to know, since in our data frame right now there is no null values, but in order to know to detect how many null values are present, we have df.isNA. df.isNA will help you detect all those features, all those values which have null values. df.dropNA will help you remove all those values where null data is present or any values are present. It will simply remove those from any kind of calculation for further in your data frame. It will simply remove it. df.fillNA 0 means fill all those NA values or invalid pixel values with the 0. So it will simply replace those NA values to 0. So simply, if let's suppose we have some invalid values like this, so it will simply replace that with 0. Or if you have NA, then it will also replace that as 0. This fill NA will do that. Drop NA will simply remove all those cells from your calculation from further operations or any kind of function you will be using after this. In terms of geospatial context, how your data, mostly geospatial data, will look like. So in pandas, you will never have in a single column, you don't really get the latitude and longitude information as a geometry altogether. But mostly you will be getting, let's suppose you will be having first column as city, second column as latitude, longitude, and population. You just store those values here like that. But can you directly plot this data? So no, you cannot really directly plot this data. I have shown you how a GIS data looks like. We have to convert this latitude, longitude later on to a geometry as a combined lat long, and then on only we can treat that data as a geospatial data. So how we convert then how we really do that. So let's suppose you have any data frame in a CSV format. So then we convert that data from a data frame to a geo data frame to finally treat it as a GIS data and then plot it, then create a map out of it, and then really do any kind of a spatial analysis that you want to do with it. So in this data, in this particular data, you can filter only the attribute information. You can select and fetch on the basis of that, but you cannot filter the data on the basis of spatial information. So in GIS, there are two concepts. One is attribute based, and another is spatial So whatever filtering selection that we will be doing, it will be divided into two things. One is attribute based, spatial based. So in Panda, with Pandas library, and the more till the point we have only data frames, we will not be able to do anything which is spatial based, which is on the basis of the location based intelligence, location based filtering, location based analysis. Will not be able to do with that. All kind of attribute based things, analysis, uh, changing the name of the columns, adding any new columns. Let's suppose we already have a population, maybe you want to calculate a city-based population density. That we can calculate. We can add a new column. We can fill out those values in that. So attribute-based, whatever you can think of, we will be able to do using that. Now there's one question you can ask, then why do we really need GeoPandas library? And then if we really can't do it, can't we just scrape the Pandas library altogether? So it's same thing like if I can do my thing, because before moving into your complete geospatial analysis, maybe geometry is just one column, is just one aspect, but maybe you have 50 parameters, attribute information with you, which you have to take care of before actually moving into the main analysis. Let's suppose you want to do a buffer, you want to do a near me analysis. So we will have to first treat all our column names that they are proper, they are correct, they are in correct data type, there are no null values in my data. Let's suppose you are storing city information, so there are no empty values present in my city columns. All the population are correct. There is no mismatch of data types, all those things. So we should clean it, correct it using the pandas library first, and then and only we should be moving towards the GeoPandas library later on. So let's suppose I create this data frame now. So we have these many information. If this is the normal data frame that you created, but let's suppose you have thousands of features in your data. Right now, we are able to visualize the whole data because it is a smaller data. But if you have a very large file with a large CSV data, you won't be able to get all the files all together. Why? Because it will take a lot of time to load. Let's suppose you have 1,000 features. It will take a lot of time to load all the data. When you are doing EDA, when you are doing exploratory data analysis, we never write DF or the variable name where you have created your data frame directly because it will take time to load everything. Instead of that, we write df.head. What df.head will help you do that? Here, df.head will help you get the first 5 feature of your data set. Df. We'll just run all these things one by one. Right now, it gives us everything. Wait. Let me add some more features into this. So you can see that df.head will help you get the first 5 feature of your whole data frame. So even if there are a million features in your data set that you are trying to load in your environment, you can only get the first 5 features. What this first 5 feature will help you with, why you will do dot head? Because it can get you a insight on how your data look like, what are the keys in your data, indexes, little representation, little look of your whole data. If I am doing df.tail, let's suppose, So it will start from the bottom. So from the bottom, it will give you the 5 features from this. In this, if I do df dot head 2, so it will give me only the 2 indexes. So that is how if I write only 4, so it will only give me 4 indexes values from my data frame. Then df dot info and describe. So df.info will give you like a more technical and like overall detailed information like indexes, what are the columns that are available, what are the non-null counts available, and what are the data type of every single column that you might have. Then here you can see that 7 non-null values means because we have values in uh, all the features here. So that's why there are no null values present into this. So it will just give you over memory use, how much space it is taking, and all those things also. df.describe, let's suppose you have like it will give you the float numbers and all those things, and a little bit more detail about the statistics as well. A basic statistics, count, mean, standard deviation, minima, quantile, 50%. These are the quantile information, the maxima, all this information about all the numerical value or the integer columns that you might have, it will give you that insight from here. So a quick, if you want to grab a quick insight about the columns, numerical columns that you have in your data set, so it can give you a quick insight from that df.describe. Any questions till now?
Not from my side.
No. Again, if you remember, the same thing from the dictionaries and list, how we used to fetch the data from that. Like we can pass on the keys name, and then we used to get the data, or we used to pass on the index name, then how we can get the data from there. So if let's suppose you want to fetch a single column information at what is present in that. So name of your data frame, and then you'll pass the name of the key or the name of the column here, any column that you want to fetch. So if you want a single column, so df city, it will give you that column information. If you want a multiple column, so simply df city, so it will give you both the column information. Okay. Can anybody tell why I'm not getting this df city information right now, and how can I get the values from both the syntaxes like this one and this one as well? What is the issue in this?
Can you just move upward so that
Yeah.
I like to check.
So this was the data frame that we had. So if I'm filtering df city, so it is giving me the city information. But when I'm writing this, it is giving me this, and it is overwriting that output from df city.
So you're asking, like expecting, like we are expecting to get 2 tables, right?
Yes, correct.
So maybe me, yeah, like I think any like different format we have tried so that we get 2 different tables.
Yeah,
I don't know.
format is right. Just one thing we are missing here, that
Is indexing
print. No, print. Because if I am just writing my syntaxes without a print statement, so what it will do, it will simply override the values to the last statement that you're writing for printing. But if I use the main benefit why actually we use print statement is it will retain the output from both of them now. So I'm getting the output from the first, and then I'm getting the output from my second syntax. That was the only difference.
Okay.
Okay. Yeah. Then in the next, how we can do the row access or the column access. So let's suppose I want to access the first row. So there's something called iloc. So iloc means location simply. So iloc 0. So it gives me just first row information here. Then there is something called lock instead of okay. So there are two things. One is iloc and another is lock. So iloc simply means based on the position, how you can filter the data from your data frame. So in iloc, your selection will be based on the integer position based. In the lock, it will be based on the label, means on the basis of the label, how you can fetch the values. In terms of how the syntax will look like, here if you see df.iloc, either you define row comma column. If you are not defining row comma column, so if I'm just writing 0, it is giving me 0th index. And if I am giving column value as well, so let's suppose 0 comma 2. So if I look here, 0 comma in this data frame, if I look, wait, if I look here, 0 comma 2, so what simply means that 0th row and the second column. So give me 77.2. So that is how on the basis of index based position, I can filter the values from this. If I change some different index, if let's suppose I am writing 2 comma 2, so it is giving, I am writing 2 comma 1. So it is second row and 0 and first index. So I'm getting 13.0. If I want to get Chennai, so let's suppose second row and 0th column. So I'm getting Chennai from here. On the basis of position, I can filter the values from this. Then, so row first will always be the row position, second will always be the column position. This will be the syntax for this. Then this df.lock. So df.lock is like a label based. it will give you basically it will give you all the rows that you have with its label, or let's suppose the indexes that you might have for that. It will just give you that information. Let's suppose right now we are not able to see the difference because we don't have any index label as such. But let's the first concept that I mentioned you about, if you can define the label. So right now we are defining the indexes label here. Instead of 0, 1, 2, I'm defining the indexes labels here. So let's suppose I am giving A, B, and C. So since in our data I have, instead of this 0, 1, 2, 3, 4, 5, 6, I am labeling this as A, B, C, D, and like that. G. So if I have till G, so I will give the labels till G here. And now if I write dear, so instead of 0, 1, 2, 3, I have A, B, C, D, E, F, G, H. So I have defined a label to the indexes as well. And because now there is nothing like 0th index as the label, I have A, B, C, D. So if I write df dot lock A, so now it will give me those values, that in the 8th row, what is there. Then if I search in the B, it is giving me B row information like that. So df.log will help you fetch the data on the basis of index label, and df.ilog will help you fetch the data on the basis of the positions of your values, or you can say the rows and column of your table in this. Okay. In the same thing, we'll see the indexing as well, the slicing thing. So let's suppose in that we have only seen in index, we have only seen right now this, that maybe first row and then second column. Just wait. Yeah. So it gives me values like this, but how can you slice the values in terms of ranges? So for ranges, for slicing, I have to use the column. The slicing concept we have seen. So this is giving me the values from first index till second. So that's why B and C. So this was the 0th, first, and second. So that's why I got B and C here. Because last index position means give me value before that index. So if the range is from 1 to 3, so that means include 3 but exclude, include 1 and exclude 3 here, like that. So if you want to fetch the value on the basis of ranges, so that is called as slicing, that we can get by using the colon and giving the ranges of the indexes that you want. But if you used lock, but remember here I am using ilock. That's why I am able to get the values on the basis of 1 and 3. But if I used dot lock, so I have to give the label. So I cannot now use like this 2 and 2 colon 3 for the slicing on the basis of label. It will give the error, because cannot do slice indexing on index with these indexers, because there is nothing like that present. Now we have indexes called A, B, and C and D like that. So if I am writing B colon D, let's suppose. So now I am getting values like this. So B colon D simply means B, C, D. Here it is not like it is excluding D and all, because it is only directly on the basis of the labels. If I am using it till G, So it will give me the value still G here. So easiest thing to remember, iloc means integer-based indexing and loc means label-based indexing in this. No other difference in this. Okay. That was about the selection. Then we'll see about the filtering. In the same data frames, let's suppose you want to filter the data on the basis of some values or the some column that you have. So in our case, let's suppose we have population column and I want to filter the data on the basis of the population. So df, wait, let me write it there on. So df means because after filtering the values from their data frame, I am just passing the value to the same data frame so that I can get it. So that is why df, I am filtering the value from where I have to save the value into the same data frame. That is why I'm mentioning df first, and then again I'm writing df because I have to filter the data from the df data frame. Then from the df, which column you have to pick? I want to pick the population column and then only give me those values where the population is greater than 15. So it is giving me only those values where the population is greater than 15. If I change the value from this to this latitude, so it will be, so if I'm writing 28, so it is only giving me those values where the population is greater than 15. Then I talked about the density concept. Let's suppose we want to create any new column into the existing data frame. So this was our original data frame. And in the same data frame, I want to add a new column. So in df, I want to add a new column called density. What value do I really want in that column? So I want in that column that I want to use the population column, which I have. And in that population column, after fetching it from the df data frame, if I divide it by 10, so I'll get the density. For example, any formula you can use here. So this was done. And then if so I now got the density column here. So you can say that without doing any kind of a loop, directly in the pandas data frame, I have done some kind of a vectorize operation and I modified all those values into every single feature that I had. So you can see now the use case of pandas here. Then let's suppose you want to sort those values. Let's suppose I have a population or I have a density and I need to do the sorting here because I need a panda. I need pandas for data analysis, for understanding my data better. So I will need sorting and all those functions. So short values is the function that we use for sorting the values that we have, all the integer value. Then how do you want to sort those values here? So by using which particular column that you want to use. So by population, and then how ascending, descending, or in what kind of format that you want to use. So if I'm writing ascending is equals to false, so that means it will arrange them in the descending order. So if I'm writing it like this, so it has arranged this into a descending order. Let's suppose I am writing this as true. So it will arrange it in ascending order like that. So sorting and all we'll need in future whenever we are doing any kind of thing. That was sorting on the basis of in the integer column. But let's suppose you have a string column. You want to sort on the basis of A, B, C, D, and like that using alphabetical order. So for that, we have the same function, sort values, and then instead of ascending and all, I will pass my column name here. So it has arranged it in the same order from this. And in case by default, it will arrange it from A, B, C, D in that format. But let's suppose you want it in other order. So we write false. Okay. So now M, D, and C. Like that, we got the order here. In some cases, maybe you have in right now, if you see that I have sorted, but indexing got changed, right? So whenever we do any kind of sorting and anything, we always make sure that we are sorting and then we are resetting the indexes again. Why? Because if I don't reset the index, when I will try to fetch the value, it will it will give me wrong values and all those things. So whenever we do any kind of a sorting and reordering in terms of the data and all those things, and our index also get manipulated. So we always make sure that we are doing the reset index. So in the same line, whenever you write any syntax for sorting, let's suppose we are doing sorting like this, and just after that, you have to use dot reset index drop is equals to true. So now when it will rearrange it, so it has resetted the index, but also it has removed your labels that we have set, because obviously labels as well, we have set it afterwards, after creating a data frame. By default, the indexes are in 0, 1, 2, 3, and 4, 5, 6 format. So you have to reset the syntax, and you can reset the syntax just like that from here. Okay, one more thing. If I am not dropping the index as true, means if I'm not dropping the previous index, your previous index will become a column and you will get the new index. So it is up to you how you want to modify or manipulate the data. Both of the things are available. So right now it has retained the previous index, the labels that you have, but converted that from an index to a column. So it is now different. But if you write drop is equals to true, then it will drop the previous indexing and just help you create a new index altogether in this, like this. Okay, so we'll close this here only for today. And after that, we'll continue with the next function of aggregation and chaining and how you can, after modifying, let's suppose till now we have modified our data, we added a new column and all, but we haven't saved that data as a .csv format. We have only created a data frame here. But if you want to save it for your future use and all those things, then how we can save all those data, we'll see that in tomorrow's session. Okay. Any questions? Anybody?
No. Yeah.
Okay.
We'll,
Okay then. Bye bye.
thank you.
Good night.
Bye bye.
Thank
Thank you.
you.
you.